Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to continue to discuss arrays. In a previous lecture, we described this foundational data structure called an array. These are a collection of variables all of the same type. You can think of them as a contiguous block of memory. The size of an array has to be specified initially, and also arrays cannot be resized in memory, once again because they're a contiguous block of memory. Now inside of Java, arrays are considered to be a special kind of object type. They're a container. So much like other class or object types, the identifier only contains the reference, in other words, the memory address to the contents of the array. Now over to the side here is the syntax for how to create an array. Just like other variables, we first must declare the array, and we use the square brackets in order to denote that this is going to be an array of this type. When we initialize an array, we have to construct it in memory. This is why we use the reserved word new, followed by the type, and then the size inside the square brackets. Again, the size has to be specified as an array is a contiguous block of memory. Now there is an alternate version for how to declare an array. We can both declare it and initialize the values all at the same time. If we know the values, we can start out by using the type, the square brackets denoting that this is an array, then the identifier, followed by the assignment, and each one of the values inside of curly braces like this. Once again, curly braces denote the body of something, and this is the body of the array, which contains each one of the values, the value at index 0, the value at index 1, etc., etc., etc. Here's an example of how we can construct an array of 5 integers, each where this is the first value, second, third, fourth, and fifth. So you can think of this as index 0, 1, 2, 3, 4, with the values 0, 1, 2, 3, and 4. As you'll learn in future courses, data structures are foundational to algorithms and computing. We use data structures to organize data in a certain way. That way we can perform certain kinds of operations on the information. Two of the most common operations is searching for information and also sorting the information. As an array is a foundational data structure, we're going to take a look at how we can both search and also sort this information using an array. First, let's discuss searching. Now this involves looking through an array for some kind of target value. Now the target value can be a specific value, but it also can be a value with a special property, like the minimum or the maximum value. Over to the side here is an example of how we can look for a specific value inside of a given array. So right here, what we do is we construct this array that we'll call A with the values 0, 1, 2, 3, 4 at indices 0, 1, 2, 3, 4. Well, that makes it easy. Then we create a Boolean found, which we initially assign to false because we haven't found whatever target value that we're going to look for. From there, we use the best friend of an array, the for loop, because we need to process every piece of data in that array. Now also keep in mind, process is more or less an empty verb. It can mean whatever. As we are searching, process means we are looking for that value. So using a for loop, we're able to look at every single value inside of this array. Now if we find the target value inside of this array, then we assign found to true. And this is a way that we can search for a specified target value in an array. Now, alternatively, we can look for a value that has a special property like the maximum value. So once again, we start out with this given array with the value 0, 1, 2, 3, 4 at the indices 0, 1, 2, 3, and 4. Now what we want to do is find the value that is maximum, the largest value. One thing that you need to keep in mind, notice that we initially assigned this max value to A at index 0, so in fact we just assign it to the value 0 here. Whenever you initially assign something like the minimum or the maximum, you should always make sure that that value is contained inside of the array. By assigning it to A at index 0, we assign it to the first value found in that array. You don't want to arbitrarily assign this value because you might accidentally introduce a value that's not even in the array. Think of it like this. If I were to assign this value arbitrarily, so I would just pick the value 5. Well, notice this, 5 is not even in this array, but 5 is greater than all the values in this array. So by the time that we search for the max value, we'll just say that it's 5, which isn't even in this array, which will cause a logic error. Whenever you're searching for a minimum or a maximum value, make sure to just choose the value that's already inside of this array. I just chose the very first value, A at index 0. Now from there, we use the best friend of an array, a for loop, that way we can process the information. Now in this case, processing means we're looking for the maximum value. So if the array at index I happens to be greater than the recorded maximum value, then we record a new maximum value. And if we run through this example, we initially assign max to 0. So then we start at index 1, not 0 this time, because we've already taken care of this first value. Now starting at index 1, we look, is 1 greater than 0? Yes. Then we record max as 1. Then we move to the next index. Is 2 greater than 1? Yes, it is. Then we re-record it as 2. Is 3 greater than 2? Yes, it is. Is 4 greater than 3? Yes, it is. And by the time that we get outside of this for loop, we will have discovered that 4 was the maximum value inside of this array. These are just two ways that we can search for values. Either we're looking for a specific value, or we're looking for a value that has a special property, like a maximum or a minimum value. Sorting data structures is also very important, and there are many algorithms in order to sort data. We're going to go over a couple of sorting algorithms to sort information, but first thing that we're going to establish is we're going to assume that we're sorting in ascending order, smallest value to the largest value. Let's first introduce an algorithm called selection sort. The idea is in selection sort, what you want to do is starting from the first index, you want to find the smallest value and make sure that that smallest value is in the first index. Then you move on to the next index and you look for the next smallest value, then the next smallest value, and etc. until you're done. Demonstrating this algorithm, let's say that we have a couple of indices and values. Let's say we have this index I, index j, and also we have this thing here which corresponds to the smallest value currently recorded. So let's just assume from the beginning that the smallest value is at index 0. Now, the I is going to keep track of which value that we're looking for. So as we're at index 0, we're looking for the first smallest value. We're then going to use j to find the smallest value, in other words, find the minimum value inside of this array. So now let's compare. The smallest value is currently 9, and then at index j, we're looking at index 2. Is 2 less than 9? Sure enough, it is. So then we reassign the smallest value to be 2, and we move j forward. Now, is 1 less than 2? Yes, it is. So we reassign the smallest value here, and we keep moving it forward. Now, is 3 less than 1? No. So we move forward. Is 5 less than 1? No. 4 less than 1? No. 8 less than 1? No. 7 less than 1? No. And we're done. The index I is keeping track of which value that we're looking for, and at index 0, we're looking for the first smallest value. We notice that the smallest value is not at that assumed index. So then what we have to do is swap those values, and now at index I, we have the first smallest value. However, as you notice, this array is not fully sorted. So then we have to move on to the next index and start that process all over again. And starting from here, we're now looking for the next smallest value. We keep running this procedure until I is all the way at the end here, and then we can confirm that yes, this array's data has been sorted from the smallest value to the largest value. Let's see an example of how this works. So we already created our project, and we're just going to create a new class, and I'm just going to call this one selection sort, include the entry point, the main method, get rid of this comment, and make sure that I put my name at the beginning here. Now in this version, we're going to accept user input, because what we are going to do is we're going to ask the user to input values, and then we're going to sort those values. So inside the main method, we set up the scanner keyboard equals new scanner system.in as we're still working through the console. The next thing that we're going to do is prompt the user. System.out.println. Welcome to the selection sort program. Enter the size of the array. Now, as we are creating an array, we understand that we have to initially give the size. So we're going to allow the user to establish how many values are going to be in this array. So then we create a variable int size and assign that to keyboard.nextInt. Now we understand that the size of the array cannot be negative, and I would argue it really shouldn't be 0 either. So we need to verify if that size is valid. If the size was less than or equal to 0, then we just immediately need to stop the program. System.out.println. That is an invalid size. And I'm going to call system.exit 0. Now, if that didn't evaluate to true, then we do have a valid size. So the first thing that we have to do is create the array. We'll just say int array, and to keep it simple, we'll call it A. And then we'll construct it as a new integer array of this given size. So what we need to do is process this information. And in this case, process means populate, or the user needs to give the information. Once again, as we need to process each element of the array, we're going to use the best friend, the for loop. For int I is equal to 0, starting at index 0. I is less than a.length I++. Now we're going to prompt the user, system.out.println. Enter value at index, and we'll just append I. From there, we need to assign A at this index is equal to keyboard.nextInt. So now this part right here creates the array and allows the user to add the information to the array one index at a time. Now I'm going to put a comment and say this is selection sort. This is the algorithm that we were discussing. There are different ways to do this. I'm going to show one way. First, what we're going to do is create for int I is equal to 0. I is less than a.length I++. In our example, we use the index I to keep track of the position. So in this case, when this first starts, this I is looking for the first smallest value. When we increase I at the end, now we're looking for the next smallest, then the next, the next, the next. When we enter the body of this for loop, we make an assumption. Int smallest index is initially assigned to I. We assume that maybe that the smallest value is at the current index. But we need to confirm that. In order to confirm that, we now create a for int j is equal to I plus 1. So as we've already assumed that the smallest index may be at index I, we just add 1 to it, thus moving it over by 1 position. J is also less than a.length j++. Now using that index j, we're going to compare it to the smallest index. We need to verify, is there a value that was smaller than what's at the smallest index? So if a at index j, so a current value that we're looking at, if this was smaller than a at index smallest index, so in other words, we did find a smaller value, then what we're going to do is reassign smallest index is equal to index j, because that is the smallest value that we have found so far. Now outside of that for loop, but still inside the outer for loop, now we need to check our assumption. If we discover that the smallest index was not equal to I, this means our initial assumption up here was incorrect. There was a smaller value at a different position as we found it inside of this for loop. Now, if this was true, we need to swap the values. Now, when we are swapping values, we need to create a temporary storage because we don't want to accidentally overwrite values. So what I'm going to do is create a temporary variable that I'll just call temp and assign this to the value at a at index I. Then we reassign a at index I is equal to a at index smallest index. So basically, we've copied over the value that's stored here into this part here. Now to make sure that we've swapped this correctly, we now need to reassign a at the smallest index is equal to what we stored in this temp value. And what we have here is the selection sort algorithm. This index keeps track of what position that we're looking for, the first smallest value, the second, third, etc., etc. We then make the assumption that maybe the smallest index, the value that we're looking for, was already at this current index. But we need to confirm that. Using this index, we then start from one position over from index I and try to find, is there a smaller value than what was recorded here? If we did find a smaller value, then we swap the values, and we do this until we have processed all of the information inside of this array. Now, we're just going to print out all the values. We're going to prompt the user, system.out.println. The sorted array is. Now, once again, we need to process every element of this array. In this case, process means print. So once again, we use the best friend of the array, the for loop, for int I is equal to 0, I is less than a.length I++. Inside the body, we process by system.out.println, a at index I. So in this example, We have populated this array, we have sorted it, and now we print the values. Let's go ahead and test it out. I'm going to say that this array is size 5. And I'm going to enter the values 5, 4, 3, 2, and 1. And sure enough, it sorted it to 1, 2, 3, 4, 5. Selection sort is just one type of sorting algorithm. Let's take a look at a different sorting algorithm. This algorithm is called bubble sort. And what this does is it looks at the side-by-side values. And whenever an element is out of order, it just swaps them. So let's assume that we have indices I and j. Now what we do is we look at them side by side. Now we determine, is I less than j? In this case, is 9 less than 2? No. So we swap the values and we move on. Is 9 less than 1? No. Swap the values, move on. Is 9 less than 3? No. Swap the values, move on. Swap the values, swap the values, swap the values, swap the values, until we're done. Now, as we have made at least one swap, we need to repeat this entire procedure over again until we have made no swaps. Now, one thing to keep track of is notice, the largest value is at the end here. Bubble sort sort of works in the opposite way that selection sort works. Selection sort was always looking for the first smallest value, then the next smallest, then the next. Bubble sort works by bubbling up the largest values. So the first time that we run this, we can guarantee that this last value is the largest value. So once again, you can consider bubble sort being kind of the inverse concept of selection sort. Now let's take a look at an example of bubble sort. Now, as you can see here, we've already created the class bubble sort, and basically we've included most of the code that we saw in selection sort. So the first part is where the user can create this array of whatever size, and then they can populate it with values. We're going to focus on the procedure of bubble sort now. Now, this is one way that we can create bubble sort. We're first going to establish Boolean has swapped and assign that to true. Now we're going to create a while loop. While has swapped. Now we establish this has swapped as being true so we can initially enter the body of this while loop. This is just a design decision on my part because this could be done with a do while loop as well. Now at the start of this while loop, we are just going to assume that maybe we haven't swapped. Has swapped is now equal to false. Now the next thing that we're going to do is look at each side-by-side element. So first, for int I is equal to 0, while I is less than a.length minus 1. We'll talk about that in a minute, I++. Now here's what we're going to look at. If a at index I, if the value that's found here happens to be greater than a at index I plus 1, this indicates that the value that is found at one index before this one was greater than this value. This means that they are out of order. If this is the case, we have to swap it. Now, in our example of going over this, we had two different values, I and j. You can think of I plus 1 as being j because it is the next value right after I. So once again, if the value before, a at index I, was greater than the value a at index I plus 1, these are out of order and we need to swap them. Once again, swapping, we're going to create a temporary value to store a at index I. Then we're going to reassign a at index I equal to its neighbor a at index I plus 1. Then we reassign a at index I plus 1 is equal to that temporary value. Now, most importantly, we have to indicate that we have swapped a value, so we reassign has swapped is equal to true. Now, the reason why we have to make a.length minus 1 is simply because we're adding this 1 here, here, and here. The thing is, if we were to keep this a.length, then what we're going to encounter is an index out of bounds exception. We're accidentally going to index into a value that does not exist. Arrays are fixed in memory, and so the last valid index is this length minus 1. But because we're adding 1 here, we may accidentally go out of bounds. So whenever you're adding a value like this, make sure that your bounds are also correct. Now, this is the code for bubble sort, and it's fairly straightforward. Now, outside of this while loop, we're just going to go ahead and have the values get printed out, just like we did before, and I'm not going to spend a lot of time on that. Now, let's test out bubble sort. Before we do that, notice that I have 2 different Java files in the same project. The thing is, you can have multiple Java files in the same project. And later on, when we get to code organization, we're going to start using a lot more classes in order to organize our code better. But in this case, what we're doing is just separating 2 different algorithms. And since both of these have a main method, whichever one that I have open and that I'm going to start running is the one that's going to run. So with bubble sort selected, we're going to go ahead and run it. So with bubble sort selected, we're going to go ahead and run it. And we're going to enter 5, and we're going to enter the values 5, 4, 3, 2, and 1. And sure enough, it sorted it as 1, 2, 3, 4, 5. In this lecture, we've gone over how we can search for values in an array and how we can sort values in an array. In future courses, you'll learn that data structures are foundational to algorithms and to computing. Being able to sort information and being able to search for information is 2 very important functionalities that are related to data structures. And with all that being said, I'll see you next time.